Hello everyone, it's Daniel from TechMine Factory and welcome to this next video from the series called IdentiSphere Explorer. In this video, I would like to talk about highly regulated identity with Auth0. So let's start. Before we start, I would like to say a big thank you to Annie Johnson, Damian Schenkelman and Ari Shapiro from Auth0 team to make it possible for me to create this video and explore Auth0 highly regulated features. Great, so now let's dive into highly regulated identity. So Auth0 highly regulated identity is Auth0 financial grade identity solution for securing sensitive data and services. It's designed for regulated industries like finance and healthcare, and HRI protects use cases such as money transfers, digital payments, and medical records access. It also enhances security for administrative changes, privilege access, and more. When talking about Auth0 highly regulated identity, it's very important to mention OpenID FAPI or OpenID Financial Grade API, which is a security standard developed by OpenID Foundation to enhance the protection of financial data in open banking and other high security environments. It builds on OAuth2 and OpenID Connect to provide strong authentication, secure API access, and robust data protection. FAPI is designed to prevent unauthorized access, mitigate risks like man-in-the-middle attacks, and ensure compliance with regulations such as PSD2. One more important detail is that Auth0 is a certified OpenID financial grade API provider. Okay, so now let's talk about Auth0 highly regulated identity features. So let's start with Strong Customer Authentication or SCA. So Strong Customer Authentication was introduced by Europe's Payment Services Directive, or PSD2 I mentioned before. It mandates the use of at least two distinct authentication factors out of the following three. Something the user knows, like a password, something the user possesses, like a device, and something intrinsic to the user, like fingerprint. And when it comes to Auth0 highly regulated identity, it provides the authentication factors to secure transactions, and here are some of them, like mobile push notifications, text messages, or WebAuthn. Strong Customer Authentication can be used with another feature available in Auth0 highly regulated identity, which is Rich Authorization Requests with dynamic linking. So PSD2 mandates payment service providers to implement dynamic linking with Strong Customer Authentication. This ensures that users validate and approve transactions by uniquely linking authorization to transaction details. In Auth0, we can use dynamic linking using Rich Authorization Requests or RAR to pass detailed transaction data to the Auth0 authorization endpoint. So the thing is that, and that's what I will be showing in my demo application, the thing is that in the application, let's try to imagine the situation that user would like to proceed with payment, and this payment is above $50. So what will happen on the application side, application will trigger authorization request on Auth0 side, and this authorization request will include authorization details. In this case, information about payment initiation. So we will see card number, recipient bank account number included in this authorization request. And now what we can do on the Auth0 side, when authorization details are included, we can decide whether user should go through step-up authentication. So to make it simple, we can decide whether user should for instance, provide OTP code from Authenticator app or the OTP code sent with text message before user can see operation details and accept them. So we will see this in my demo application, but the thing is that before user can accept transaction, then user is redirected to Auth0. Auth0 requires user to go through step-up authentication. So like, for instance, to provide OTP code from Authenticator app. Then Auth0 is displaying operation details, as we can see on the right side, like transaction type, card number, or amount. And then user can decide whether to decline this operation or to accept. And obviously, if user accepts this operation, then the access token that is returned to the application contains authorization details. So then application can call Payment API, for instance, and Payment API can look into the access token, extract money transfer details, and proceed with payment. Very powerful. And important fact is that when it comes to Rich Authorization Requests with dynamic linking, we can leverage Auth0 actions to customize the authentication flow. So as you can see on the right side, I have the post login trigger here, and I included validate authorization transaction details action here. So after the user logs in, we can inspect transaction details received via RAR using Auth0 actions and decide to whether user should use step-up authentication or not. So as we can see here on the right side, there is a code from my Auth0 action. And as we can see, if there is any transaction included, we want user to go through MFA process. But first we have to actually check whether user has MFA enabled. If user doesn't have MFA enabled, we actually deny this operation and we return error to the application. Like, you must enroll in multi-factor authentication first, operation is blocked. However, if user has any, multi-factor authentication method registered, then we ask user to go through the MFA. So for instance, to provide the OTP code from the Authenticator application. So again, this is really, really powerful. Another great feature that is supported by Auth0 Highly Regulated Identity is Pushed Authorization Requests, or PAR. So PAR adds an endpoint for clients to push Auth0 authorization requests directly to the server. This prevents exposing authorization parameters via the insecure front channel in the browser URL, reducing interception risks. So authorization request is first sent to the OAuth PAR endpoint using HTTP post. And then Auth0 returns request URI, which application uses when calling standard authorized endpoint. So let's look at this example here. So this is example of pushed authorization requests. So as we can see, when we call authorized endpoint on Auth0 side, we only provide client ID and request URI, which was previously returned from PAR endpoint when we used HTTP post method. So even if we look into the browser DevTools under Network tab, we only see client ID and request URI. No other parameters like scopes or authorization details that we use in Rich Authorization Requests. So it's way more secure. And the thing is that this request URI is one-time use. So after user successful authentication, if we try to use it again, Auth0 will block such operation. Perfect. So now let's talk about another feature, which is JWT-Secured Authorization Request, or JAR. So JWT-Secured Authorization Request is an extension of the OAuth2 protocol and adds a layer of security to protect the integrity of authorization request parameters. In the authorization code flow, the client wraps parameters in a signed JWT before sending them to authorized or OAuth PAR endpoints. And then JWT is signed using the private key known only by the client application. So that's very important. So application before contacting authorized or OAuth PAR endpoint, application is actually creating this JWT, which is signed with the private key that only application knows, and then this JWT is sent to authorized or PAR endpoints. And the thing is that the authorization server, which is Auth0, verifies the signature with client's public key, extracts request parameters, and processes them securely, ensuring authenticity and preventing tampering. So that's very important here. Like, we can use JWT-Secured Authorization Requests with standard authorized endpoint and with PAR endpoint. So it's really great feature. When we look at this slide, it presents actually this verification. So on the left side in Auth0 for our application under Credentials tab, we have to upload the public key that is actually used to verify the signature on the JWT sent by the application, which is signed with the private key that only application knows. And as you can see, under the KID claim, under header, we have the key ID, which is then used to tell the Auth0 which credential should be used to check the signature on this JWT. So it's really powerful. So as I mentioned before, we can use JWT Secure Authorization Requests with both standard authorized endpoint and with a Push Authorization Request endpoint. Another great feature to enhance security is sensitive data protection in access tokens with JSON Web Encryption. So Auth0 Highly Regulated Identity supports JSON Web Encryption to secure access token payloads. This protects access tokens from application-side data breaches and unauthorized inspection into API calls by intermediaries. Token payload is encrypted and cannot be inspected by the client application. So Auth0 encrypts the token using the public key, and when API receives the encrypted token, it decrypts it using the private key. In many scenarios, to authenticate the client ID and client secret values are used. However, Auth0 Highly Regulated Identity provides stronger application authentication. To improve application authentication security, Auth0 Highly Regulated Identity offers two different alternatives as a part of the FAPI1 Advanced Security Profile. First one is Private Key JWT. This involves generating a public-private key pair to use as credentials to authenticate an application, or we can use MTLS for OAuth. This involves registering a standard certificate linked to an application on Auth0 tenant. Their certificate can either be CA issued or self-issued. The client issues the certificate's private key to establish an MTLS tunnel for Auth0 tenant requests. In the demo application I will be presenting in this video, we are going to see how to use private key JWT for client authentication. There are two other great features that Auth0 provides. The first one is access token protection with token binding. So sender constraining, also called token binding, enables the binding of the access token to cryptographic keys such as private key. It enforces that only the application that requested the access token can use it to access the associated resource, thus mitigating token theft and reply attack. Token binding links the client certificate thumbprint to an access token, allowing the API server to verify the client's certificate. This prevents unauthorized access even if the token is compromised. Token binding in Auth0 operates independently of the application's authentication method. We can use private key JWT authentication and does not require the pre-registration of the client certificate. The last great feature is customer managed keys. So customer managed keys in Auth0 allow organizations to use their own encryption keys to secure sensitive data instead of relying on Auth0 default encryption. This provides greater control over data security, compliance, and key rotation policies. Auth0 secures tenants' secrets and data using an Auth0 environment root key at the top of the envelope encryption key hierarchy. The Auth0 environment root key and customer-provided root key are stored in the hardware security module of the corresponding Auth0 cloud service provider, AWS or Azure Cloud. Perfect, so that's about features review and theory. Now it's time to see it in practice, so let's jump into practical demo. So here is the Blazor web application I created with .NET C#. This application is secured with Auth0. So now let's see the full scenario before we jump into technical details. So when I click New Payment tab, we can see the information that I have to authenticate first. So I will click Login button and now I'm redirected to the authorization endpoint. And from there, obviously, I have to provide my username, I have to provide my password for this specific user, and because of the fact that I have MFA enabled for my Auth0 tenant, I have to also provide the code from the Authenticator app. So I will provide it now, and once I'm successfully authenticated, I'm redirected back to my IdentiSphere web application. And now when I click New Payment tab, we can see that now I can proceed with a new payment. And obviously, this is just for the demo purpose, so it's simplified. But I would like to present how actually we can leverage Auth0 highly regulated features to build more secure applications in regulated industries. So as we can see, here I have to provide the amount. So let's say that it will be $400. I have to provide the card number here. So I will type some card number, some fake card number. I have to provide security code for this card number. I have to select the expiry date. So let's say that it will be in 27. And like this. And also I have to provide the card holder. So Daniel Tester. The recipient will be Andy Moore. And also recipient bank account will be this one. And now I will click Proceed button. And what's happening right now, I'm redirected to Auth0, as you can see. So before I can actually accept or proceed with this payment, I have to go through the verification process. So now, again, I have to provide the code from my Authenticator app. So this is my OTP code. I will click Continue button, and now I can see operation details that are displayed here. So I can see that transaction type is payment initiation. I can see the card number, recipient bank account number, recipient name, and the amount. So $400. And now I can either decline or accept this transaction. So actually, if I accept this transaction, Auth0 will issue the access token, which then I can use to call Payment API to proceed with this payment. So I will click Accept button, and as we can see, the information payment initiated successfully. So now, because of the fact that I went through the step-up authentication process, I also accepted this transaction, then this payment initiation was successful actually. So perfect. So that's how it works. And obviously, if I decline this transaction, Auth0 will not issue any access token. That's one thing, okay? And the second thing is that this decision about whether to display MFA step or not can be done using Auth0 actions, what we will see. So actually in this scenario, I require user to go through the step-up authentication every time there is some transaction request sent to Auth0. But obviously we can implement this in another way. So if the amount, let's say, is higher than, let's say, $1,000, then we require step-up authentication from the user. So it's really powerful. So now, as we can see, this payment was initiated. That's great. So now let's discuss some technical details that are happening underneath in this application, and also a web API created with ASP.NET Core. However, let me show you one more example with the user who hasn't configured MFA. So I'm clicking Login button. I'm redirected to authorization endpoint. This time I will use Andy's account. I will click Continue. I will provide the password, and great, I'm successfully authenticated. But now let's see what will happen if Andy will try to proceed with the new payment. So here, let's provide the amount. Again, let's provide some card number. It can be fake just for the demo purpose. And again, I have to provide the expiry date like this. Card holder will be Andy Moore. In this case, recipient will be Daniel Tester and recipient bank account will be like this. And I will click Proceed button. And as we can see, now there is information. You must enroll in multi-factor authentication first. Operation blocked. So what happened underneath, Auth0 received this request, but because of the fact that I have this Auth0 action configured, which actually verifies whether user has MFA configured or not, if user doesn't have MFA configured, we will block this operation. And it means that Auth0 will not return an access token that can be used with the payment API. Okay, perfect. So now let's jump into Auth0 dashboard to see how things are configured there. So here is Auth0 dashboard with my tenant. Before we continue, it's very important to understand that all those features which I will present for highly regulated identity are available under enterprise plan with some additional add-ons enabled. So thanks to Auth0 team, my tenant was enabled with enterprise plan and those additional add-ons were also enabled. So I was able to test all those features. Okay, perfect. So here is my IdentiSphere web application registered. And under Settings tab, if we scroll down, we can see that under Authorization Requests, I have two toggles enabled. Require Push Authorization Requests and require JWT-Secured Authorization Requests. And as you can see, this one is add-on that is enabled for my enterprise plan. Okay, perfect. So now, first of all, I want my application to use push authorization requests. So instead of including all those, details like scopes or authorization details directly as a parameters to authorize endpoint, I want to use push authorization requests. So use this HTTP post method to push those parameters securely using backchannel to Auth0, and then to use authorize endpoint only with client ID and request URI. So I have to enable this toggle here. Important information is that under tenant settings, we have to also enable this toggle. So allow push authorization requests for our tenant. Okay, so that's very important to enable it. Once it's enabled, we can start using push authorization requests in our application. So now let's see the application code and what's happening there. So here is my Blazor web application source code and solution open in the Visual Studio. And before we continue, it's very important to mention that pushed authorization requests feature was added in .NET 9. So actually I used .NET 9 to create this Blazor application. And now under OpenID Connect options, we have this additional property, pushed authorization behavior. And now we have three options to choose from. So we can select disable. So in this way, in this case, we will not use PAR approach at all. So in this case, we will just use standard approach where we send all the parameters to authorization endpoint through the front channel. We can select use if available. So in this case, if identity provider supports push authorization requests, then we want to use it, or we can set it to require. So it means that we always want our application to use push authorization requests. Great. So now what will happen when user clicks login button, instead of sending all those parameters in a front channel, actually, our application will make an HTTP post to Auth0 PAR endpoint. Application will pass all those parameters in the HTTP post body, and in a response, actually, Auth0 will return this unique parameter that then can be used to call authorization endpoint. Okay? So it's very important to understand that instead of sending all those parameters in a front channel, we are using the back channel. So actually we are using HTTP post method to send all those parameters to Auth0. Okay? And Auth0 will actually return this specific URI, which can be then used with client ID to call authorization requests. So now let me show you this behavior in a browser. So here is the application launched, and on the right side I have network tab open with the activity, so we can track what's happening from the networking perspective. So I'm clicking login button, and for now I can disable recording the network activity, because what I'm looking for is the call to authorize endpoint. So let's open it actually and let's see it. As we can see, under query string parameters, we only have client ID and request URI. So this URI I mentioned before, that is returned from Auth0 once we call par endpoint. So the flow is this. Our application using the back channel is calling par endpoint on Auth0 side using HTTP post method. In the request body, all the parameters, authorization parameters, are passed to Auth0. Auth0 is recording those parameters, is creating request URI, and is returning this request URI to our application. And then our application is calling standard authorized endpoint on Auth0 side with client ID and this request URI unique value. And then, obviously, once the user is successfully authenticated, Auth0 is redirecting user back to the application with ID token and optionally with also access and refresh tokens. So that's about push authorization requests. So it's way more secure, as you can see, because we don't have any authorization parameters exposed directly in the browser. Another feature which I would like to present in this demo is stronger application authentication. So as you remember, when I was presenting, I mentioned that typically client ID and client secret values are used to authenticate client. However, there are stronger methods like MTLS and private key JWT. So in this demo, I would like to show you how to use private key JWT to authenticate application instead of using client secret. So to change application authentication method for our application registered in Auth0, we have to open application in Auth0, and under credentials tab, under application authentication, we can select authentication method. So in this case, I'm selecting private key JWT. And then I'm clicking Save button. That's not the end, because if we scroll down here, we can see that under credentials, I can add credential that will be used to actually validate this private key JWT. So when I click Add Credential, this tab is open here, and I can decide which type of credential I want to upload, whether it will be public key, certificate, CA signed, or certificate self-signed. So in this case, I uploaded public key, and as we can see, this public key is used for private key JWT and also for JWT-Secured Authorization Requests, so JAR requests. I want to mention one very important thing here. For the demo purpose, I'm using the same public key here. However, Auth0 strongly recommends using separate public keys for private key JWT authentication and separate for other operations like for JWT Secured Authorization Requests. So that's very important. For the demo purpose, I'm just using one public key to just show those scenarios. However, in a real-world scenario, you should use separate set of credentials to support each scenario, like private key JWT application authentication and JAR requests. Perfect. So once we upload our public key here to Auth0, we can, on the application side, implement private key JWT authentication. So let's dive into the code of the Blazor application now. So here is the Blazor web application source code open in the Visual Studio. So now important fact is that under OpenID Connect events, we have this special event called onAuthorization code receive. And this event is always fired when Auth0 returns authorization code to application, which then can be exchanged for tokens. And typically, to exchange code for a token, we use client ID and client secret for client authentication. However, instead of using client secret, we want to use private key JWT. So to use private key JWT, we actually need to create this JWT using our private key, okay, to sign it actually with our private key. So to do it, we have to build this token, we have to mint it. So that's why I have this class called JWT Token Builder with the method called Build Client Assertion Token. Let's look at this method here. So first of all, we have to load our certificate file and we have to provide the password to open the file. And then we have to create signing credentials using this certificate, okay? So once we have it actually, we have to obviously build the token I mentioned before. So first of all, we have to create a JTI claim, which is actually unique grid that we're creating here. And we have to provide the subclaim, which is actually the client ID of our application, okay? And now what's happening here, we are creating this JWT token using the client ID, audience, claims, and also important thing is that we are providing this signing credential with our certificate with private key. And also important thing is that here we have to update the header and the keyed claim actually to make sure that this keyed value actually matches the key ID credential in Auth0 dashboard. That's very important. To make it work, this key here has to match the key ID of our credential that we uploaded in Auth0 dashboard as I showed you before. And then we are creating this token, we are minting this. So once we have this token here, so client assertion token, what we do, we have to refer to token endpoint request, client assertion type. We have to change it to JWT barrier instead of using typical client secret. And under client assertion property, we have to provide this minted JWT token, which is signed with our private key. And now, once this token is created and application is exchanging code for a token, application is providing this client assertion token. And then Auth0 is using this public key, which we have actually in Auth0 dashboard where we uploaded it. And Auth0 is checking whether this JWT token was actually signed with this application, which is the owner of the private key. And obviously, after a successful authentication for the client, Auth0 is returning tokens. So that's how it works, actually. So in this specific scenario, instead of using client secret, we can use this private key JWT. So in this case, we use public keys and private keys to make this validation, which is way more secure than just using a static value, which is a client secret. So now if we try to debug this functionality after successful user authentication, once our application receives the code and tries to exchange this code for a token, we are creating this client assertion token. And if we look into this token and we decode it, we can see that first of all, under the key ID claim in the header, we have the ID of our key ID in the Auth0 dashboard for our credential. And also in the payload under subject, there is client ID of our application, which is also the issuer. And there is audience, which is actually our Auth0 domain. Okay, so in this specific scenario, we are providing this private key JWT instead of client secret. So now if we copy this keyed claim value or key ID value and we go to Auth0 dashboard, we will see that it will match the key ID there. So let's check it. So here in the Auth0 dashboard, if I try to find this key ID, we can see that this is our IdentiSphere public key that is uploaded here in Auth0 dashboard for this application. So now when Auth0 will receive this request, it will use this credential, this public key to actually validate the signature of this JWT that was sent. And then after successful validation, Auth0 will return tokens to application. Great. So let's explore some more features in Auth0 Highly Regulated Identity. So now I would like to present how to use JWT-Secured Authorization Requests. So in Auth0 dashboard, under Settings for our register application, if we scroll down, we can see this toggle, Require JWT-Secured Authorization Requests, or JAR. So when required, authorization request parameters must be wrapped in a signed JSON Web Token for cryptography confirmed non-repudiation. So it means that we have to wrap all the authorization request parameters in JWT token, which will be signed with the private key that our application owns. And then when the request is sent to Auth0, Auth0 will use the public key that we uploaded under credentials for our application, will check the integrity of parameters, and then we'll proceed with other operations. So in this specific scenario, we can be sure that nobody tampered like those authorization parameters in the middle, okay? So in this specific scenario, we will see how to use JWT Secured Authorization Requests. So now let's jump into Visual Studio. So let's take a look at this code. So under OpenID Connect events, I have this onPush authorization event, okay? And this event is invoked before authorization parameters are pushed using PAR. So push authorization requests. So as you remember, for this application, I configure push authorization requests. So now, before we send anything to PAR endpoint, we want to include this jar token I mentioned before, okay? So obviously, we have to mint this token. So for that, I'm using JWT token builder class again, but this time I'm using build jar token method. And when we look at token builder class and build jar token method, we can see that here I'm providing audience, certificate password, jar token key ID, and also additional parameters. So what's happening in this specific method? So obviously we are loading the certificate here from the pfx file with the password. We are creating signing credential here. And it's important to mention that under claims, we are including all the parameters that will be used by a PAR endpoint. So client ID, response type, scope, redirect URI, state, and nonce. Everything has to be included in claims here that will be included in the payload of this JWT. For now, please ignore those two lines here, like authorization details and audience. Authorization details, we will explain this when I will be talking about rich authorization requests. And also here, when it comes to audience, we want to include audience claim only when we are requesting an access token, okay, from Auth0. So if there is no audience, then we don't want to include this claim in the jar token. And in the end, what we are doing here, obviously, we are creating or minting this jar token here. So we are providing the client ID, audience, claims, and also important fact is that we have to sign this JWT with our private key, which we have because actually we loaded it from the pfx file here. And obviously, we have to update the key ID header or keyed header, keyed claim in the header of this token, because this key ID has to match the key ID of the credential that we uploaded for our application under credentials tab. So again, this key ID is very important because if this key ID doesn't match the ID of the key in Auth0, then we will not be able to successfully authenticate. Okay, great. So then we are creating this token. And in the end, what's happening here, as we can see, here we have to use handle client authentication. So this tells the handler to skip setting client authentication properties for push authorization. Okay. And here we want to use client assertion, not client secret. So that's why we have to use this method. So we are providing the client assertion token. This is what I discussed before for stronger application authentication. And also, as you can see, as one of the parameters, I'm adding this jar token under request parameter. when I will be calling a power endpoint on Auth0 side. So this jar token has to be put under request parameter, and then we can send this request to power endpoint on Auth0 side. And now what will happen? Auth0 will receive this jar token. Auth0 will verify and check the signature for the token using the public key that we uploaded under credentials for our application. Auth0 will also look into the keyed claim under the header to check key ID, and will check which credential has this key ID in Auth0, and we'll use this credential to actually check the signature, okay? And we'll verify whether this request was not tampered. And in the end, obviously, it will proceed like in any other scenario. So in the end, it will return this request URI, and then our application can call authorize endpoint and then exchange the code for a token. So actually, this is how this mechanism works. So again, if we try to debug this functionality and we will decode jar token, we can see that under the payload we have all the parameters like client ID, response type, scope, and all other things that are required here. And in the header under key ID, we have the ID of our credential that we registered for our application in Auth0 dashboard. So now what will happen, Auth0 will look into this payload and also will check the signature using the credential with this key ID, and then Auth0 will return authorization code, and then application can exchange this code for token. Great. So that's it about jar mechanism. Now let's talk about Rich Authorization Requests. When it comes to Rich Authorization Requests, it's important to understand how different things work underneath and how actually it's configured. So let's analyze the flow again. So here is the web application. If I open new payment tab, obviously there is information that I have to authenticate first. Okay? So I click login button. I'm obviously redirected to Auth0 to authenticate. I have to provide my username. I have to provide my password. And obviously, because of the fact that I have MFA enabled for my tenant, I have to also provide OTP code from my authenticator application. So let me do it now. Once I provided the code, I'm successfully authenticated. Perfect. So all the things I mentioned before in this video, so push authorization request, JWT-Secured Authorization Requests, all those things are in place. And now we are adding two more things actually. So we are adding Rich Authorization Request. So we want to include authorization details in the request to Auth0 when user authenticates. And also we want to include those authorization details in the access token that will be returned to the application after user is successfully authenticated. So this access token can be then sent to payment API so it can initiate the payment actually. And the second thing is that obviously this access token that will be sent to payment API, the data in the payload when it comes to payment details, it's confidential. So it's better to encrypt this data to make sure that it's stored confidentially, and only payment API can actually decrypt the information in the payload and can use it to proceed with payment. So let's understand this flow. So when I click new payment here, important thing is that right now I do not have any access token. Just to make it clear, no access token right now in this web application. I'm providing the amount, so $50. I have to provide the card number. Let's use some fake card number, some fake security code. I will select also expiry date like this. I'm providing my cardholder name. Recipient will be Andy Moore. And obviously here I'm providing some fake bank account, okay? Now I'm clicking proceed. And what's happening here? I'm redirected to Auth0. but this time I'm using audience claim because I want to obtain an access token to call payment API. However, in this authorization request, I include as a parameter authorization details. I include this information about the payment, about the bank account, about the amount, about the card holder, and about recipient, okay? And this information is actually sent to Auth0. So now what's happening, because of the fact that I have Auth0 action configured, which is looking into the request, I will be able to control whether I want user to go through step-up authentication, okay? So this Auth0 action is using post login trigger actually, and this action is responsible for looking into the request, and if there are authorization details included, then Auth0 will request the user to go through the step-up authentication process. So as you can see here, I have my authenticator app registered, and I'm asked to provide the code from my authenticator app. So I'm providing the code, and then Auth0 is displaying operation details. So I see transaction type, payment initiation, I see the card number, recipient bank account number, recipient name, and amount, $50 as we said in the application. And now I can either decline or accept this operation actually. If I decline, obviously no access token will be returned from Auth0, and we cannot proceed with payment initiation. However, if I click accept button, what will happen underneath, let me do it, Auth0 will return an access token. Obviously I see this confirmation, payment initiated successfully, but underneath what will happen, Auth0 will return an access token, and this access token has authorization details included and information about this payment. So it's in the access token payload, which we will see in this video. And actually, additionally, token payload is encrypted, okay? And then when this access token is sent to payment API, which we will see, API will decrypt the token payload, will look into authorization details, and then it will proceed with the payment initiation. Okay, perfect. So now let's look into technical details. So let's start with Auth0 dashboard. So here is my IdentiSphere API application registered. And under permissions, if we scroll down, we can see that here I can add authorization details types. Okay, so this is like a list. So here I have only one authorization details type, payment initiation. So this is the type I will be using in my Blazor application with Auth0. Okay, and obviously this information is required because then Auth0 will include authorization details information in the payload of the access token for this API. Now let me switch to settings also. And as you remember, I mentioned that token payload, access token payload to be more precise, is encrypted when it's returned from Auth0. So under the settings, as you can see under JSON Web Encryption, I have this toggle enabled. So as you can see, signed access tokens will be also encrypted. Okay, the payload of the access token will be encrypted. And obviously here, as you can see, I have to provide the certificate or the public key that will be used to actually encrypt this. So if I click rotate, you can see that here I can add encryption key, okay, public key encoded in PEM format. And also I can select JSON Web Encryption algorithm here, okay? And additionally, I have to provide the key ID, as you can see, okay? And when I add this public key here, you can see it's visible under JSON Web Encryption. So Auth0 will use this public key to actually encrypt the token payload, and then Payment API will use the private key to decrypt this. Okay, so that's very important. So this access token will contain authorization details. However, to make it even more secure, the payload of the access token will be encrypted. Okay, perfect. So now let's jump into the source code of web application to understand what's happening there. Okay, so here is the source code of Blazor application in the Visual Studio. So let's start with the payment side, actually, payment page, okay? So as we can see, there is proceed with payment async method. And this method is invoked when I click proceed button, this green button on the UI, okay? And obviously, first of all, we have to check in Blazor whether a user is authenticated, okay? So for that, we're using authentication state provider. And once we verify that user is authenticated, we want to collect all the details that user provided through the UI, okay? So amount, card number, recipient bank account number, and so on and so forth. And once we have all those details, we are not sending anything yet to Payment API. We want to first call Auth0, actually, an authorization endpoint. So as we can see here, we are setting this authorization details parameter using secure parameter service because we want to pass this information to another component which will be handling this redirection. And we are using navigation manager and we are navigating to login page. However, we also adding this action which is RAR transaction, which is actually Rich Authorization Request transaction, okay? And then what will happen if we go to Identity Service Collection extensions, in this event called onPush authorization, as you remember, we are using Pushed Authorization Requests here. We are checking whether action in the context request equals RAR transaction. So whether it's a Rich Authorization Request actually. If it is a Rich Authorization Request, we use secure parameter service to retrieve authorization details, okay? And here, obviously, we have to create this list with authorization details, because as you remember, this is our list on Auth0 side for our API. We can have multiple authorization details. But for that, I'm only using this one type, okay, as you remember. So payment initiation, okay? So only one type for authorization details. And now we have to serialize this as JSON. So that's pretty obvious. And once we serialize this as JSON, we are setting this parameter in authorization request. So we are putting authorization details here with this serialized information about authorization details. And obviously, we are setting the audience parameter, which is the audience of our web API registered in Auth0. So this is the audience, the identifier of our API in Auth0. So in this specific case, IdentiSphere API. And as you can see, all other things will stay as they are. So we are building jar token. This is what we explained before. We are creating client assertion token. And then we are obviously pushing this request to Power Endpoint on Auth0 side. And what will happen? Auth0 will look into this authorization request, will look into the parameters, will also check whether there are authorization details. And if there are authorization details, obviously step-up authentication will be triggered because of the fact that I configured this Auth0 action. So let's look at this Auth0 action now. So here is Auth0 dashboard again, and under actions and triggers, as we can see, we have different kinds of triggers. In this specific scenario, I want to use post-login trigger, okay? And here we can see the flow. Obviously, I'm adding additional user attributes to access token. That's not a part of this video. It's not important. Important thing is that I have this second action here, which is called validate authorization transaction details. So if I click this and I will open its source code, you can see that this is actually the source code for this Auth0 action. It's not complicated. The thing is that on executing post-login, so actually when user is successfully authenticated, we want to look into transaction. And we want to check whether there is some transaction and there are request authorization details included. And if there are any authorization details included, we want to check if the type of actually this detail is payment initiation. Okay, so we are checking the type in the request. And if this is payment initiation, we want to actually check if user has MFA enabled. Okay, so this line is actually responsible for that. So we are checking whether user has any multi-factor authentication enabled. So if user doesn't have any MFA registered, we are returning error, like you must enroll in multi-factor authentication first, operation block. So Auth0 will not return any access token. However, if user has any MFA methods registered, then we are asking the user to actually go through the MFA process. So to go through the step-up authentication process. So that's why in the demo application, as you saw, I had to additionally provide this OTP code from my authenticator app. Okay? And when user confirms this with OTP code, we are setting transaction ID in the access token. This is very helpful from the debugging perspective and correlation perspective. So it's worth to add it here in the access token. And after that, what will happen? Auth0 will also display this screen with the operation details, as you saw. So the information from authorization details will be extracted, and Auth0 will display this information like, hey, do you want to proceed with this operation, like payment initiation with this amount for this recipient, and so on and so forth. And then user can decline or accept. If user accepts, then Auth0 is returning an access token. And as you remember, this access token has encrypted payload. Perfect. So now let's look into this access token, and then let's look into API code to see how actually the request is handled there. So here is Blazor web application source code again. And as we can see, there is this event, on token response received. So this event is actually triggered when we receive an access token from Auth0. So here in the debug mode, we can actually open this access token. And as you can see, there is information that Visual Studio is unable to parse JWT payload. Why? Because it's encrypted. So Auth0 in the header of this access token is including information about the algorithm and encryption. Okay, so we need to use this information on the API side to actually decrypt this payload of this access token. So now, before I will jump into the source code of API application, I want to show you one more thing. So once we obtain the access token from Auth0, if I go back to payment page, I will click continue. We can see that we still have this access token with encrypted payload. So here we are using HTTP client to call payment API. Okay, so here is the endpoint API payment init. So this endpoint is used to initiate payment. And also important fact is, if I click continue, that here as a body, we are including payment details, money transfer details. Okay, so in the request body, we are including this information. So then payment API can look into this request, can look into authorization details in the access token, compare the values, process it, and then make a decision whether to proceed with payment initiation or not. Okay, so here, if I click continue, then obviously this request is sent to a payment API, and then payment is initiated. So now let's look into the API source code. So this is the source code of my ASP.NET Core Web API that is called by Blazor Web Application with an access token obtained from Auth0, okay? And here under JWT barrier events, I have this special event called onMessageReceive. So it's called every time we'll receive any message in this web API, okay? And here what I can do, I can check or look into request headers and extract authorization header. So as we can see, I have this barrier access token included in authorization header, okay? And then what I have to do, obviously I have to extract its value. So let me open parameter here. And as we will see, still Visual Studio is unable to parse JWT payload. Obviously, it cannot because it's encrypted by Auth0. So now on the API side, I'm using token decryptor class and decrypt token method. So if I open its definition, you can see that here, again, I'm loading the private key from the PFX file, which is secure with password. And then I'm using this decrypt method here to decrypt the token that was sent using the private key loaded from PFX file, okay? And then this method is returning decrypted token. So if I get back here, and I will put breakpoint here just to make sure that we can see it, I will click continue. Now, if I try to open the token, you can see that now the token payload is decrypted, and now I can see the payload. An important fact is, please notice that here in the payload, I have authorization details included. I have this information about the payment initiation. I have money transfer details like card number, recipient name, or amount, okay? And now, once I have this access token decrypted, now what I can do, actually, I can proceed here in this initiate payment async method, which is called actually when the payment initiation endpoint is called on the API side. And here, as we can see, I'm extracting information from the HTTP body, okay? And what I'm doing here, I'm comparing this to actually information about authorization details included in the authorization details in the access token, okay? So as we can see here, I'm extracting authorization details from an access token. So I have them here. I can open them as JSON, as you can see here. Payment initiation, amount $50, recipient name Andy Moore. And also, I'm comparing this against the data that was sent in the HTTP post body. Okay, and this is simple check. Obviously, it's for the demo purpose. So you know, like if actually card number matches the card number from if card number from the HTTP post body matches the card number from the authorization details in the access token, and if the amount from the HTTP request body matches the amount from the authorization details from an access token, we are returning HTTP OK 200. Okay, simple as that. Obviously, in the real world scenario, many more things could happen here, and this validation should be more secure and more strict, but this is only for the demo purpose, just to show you this. Okay, so once API will return OK, then Blazor app can receive this response and then can display this information to the user like, hey, payment initiated successfully. Great, that's it. I hope you enjoyed this video as much as I did. If you would like to learn more about highly regulated identity from Auth0, I strongly recommend visiting this official page that Auth0 provides. And if you would like to learn more about identity topics and secure application development in the cloud, I strongly recommend visiting my techmindfactory.com blog. Thank you so much for watching, and see you in the next videos.